Hi, we're students in Iowa State University's Industrial and Manufacturing Systems Engineering Senior Design course. My name is Erin Mitchell.
I'm Alexander Petulakis.
I'm Kelly Hartgen.
This semester, we worked with Elkay Manufacturing in Savannah, Illinois, which produces water fountains, water coolers, and bottle fillers. Elkay is experiencing tremendous growth on their EZ line, which means that there has been a drastic increase in demand that is expected to continue over the coming years.
This means their takt time will decrease from 1.61 minutes per unit to 1.18 minutes per unit by 2020. Their assembly line is not currently equipped to obtain this throughput rate. In addition, there are many opportunities for improvement in the processes that precede the assembly area. For example, the 20-minute vacuum drawdown process ensures no contaminants exist in the cooler's plumbing. Because the loading takes much longer than the unloading operator often has long waiting times, or the gantries that hold the units are sent unfulfilled. Investing in a system that decreases the cycle time and decreasing the batch size from 4 to 2, we've made recommendations that ensure that this will not severely limit production.
Through time studies, we determined that the lines were unbalanced, with cycle times on individual stations ranging from 67.4 seconds to 102.5 seconds. Many tasks, such as the cleaning and material gathering, are completed on different stations depending on the daily required rate, where each operator is stationed that shift. In our recommendations, we eliminated non-value-added tasks such as movement to gather and replace tools. Through our time studies and work sampling, we also recommended changes to some workstations' layouts and suggested that visual signals be installed for the test benches, so overprocessing is avoided. Elkay will also need to add 1 or 2 stations to enable the assembly area to meet the rate of customer demand.
Finally, we observed a starvation issue to the assembly area due to the logic of the conveyor system. On the first day of observation, the EZ line was without units 6.4% of the time. On the second day, it was without units 14.5% of the time. This issue also impacts the other line that is fed through this conveyor system. In order to get more units, the operators walk down to the safety stock area and physically drag the units across the conveyor to their workstations. In order to accommodate the necessary throughput rate, the lines must have the units they need on time, so the conveyor's logic must be reprogrammed.
If these improvements are made, the assembly area will be able to meet the 71 seconds per unit takt time and produce 34% more EZ units as they are today, while remaining in the same footprint and with 1 or 2 additional operators in the area. This will require investment in a new drawdown system, improvements to the test benches in the assembly area to reduce cycle times below the takt time, reprogramming the conveyor logic, and reorganization of some workstations for reduction of non-value-added time.
Through the efforts of the engineering team in Savannah and the help of many operators, we've been able to target the most important improvements to tackle in the next year, as well as give an idea of where the next steps could be. Elkay is anticipating great opportunities to grow their business, and by committing to improvements around their EZ assembly area, the Savannah plant will play a huge part in reaching their goals.